Hey guys, welcome to the Unit 6 exam review. Our goals are pretty simple for today. We just want to review and get ready for the test. For the review today, what I did was I went through your quiz from last week and I picked out the problems that I felt like you needed to work on most, probably the ones that you struggled with the most on the quiz. So I'm going to go through a few of those today, and if you need to practice anything else, if you need to practice rewriting or going from log form to exponential form, you can go back through the old MyOpen Math assignments that we've already done and practice those again inside of those assignments. All right, so let's take a look at our first problem here. One of the problems that we struggled with last week on the quiz was this factor and solve question. Real quick, I made a typo here. I want you to change this to a plus, all right, on the notes. So that should be a plus. I accidentally hit a minus, so make sure you change that. All right, and then we're going to do this factor and solve. All right, so I use the box and diamond method for factoring. So this is a question that specifically addresses your knowledge on the box and diamond method. So I added my diamond over here on the right, and then this is our box, or what we call the generic rectangle. And in MyOpen Math, you have to fill in this generic rectangle, and you have to get all four of these boxes correct here. So the first two boxes we can fill in very easily are this first term, this 3x squared, which goes in the upper left-hand box. And then the constant on the end here, this plus 3, is going to go in the bottom right-hand box. Okay. And then this is where I would stop and I would focus on these two questions that they ask you. What will the diagonals multiply to, and what will the 2x terms add to? All right, so the diagonals, right, if we look at the diagonals, when we talk about the diagonals, we're talking about these right here, right? So this is a diagonal here, and then this would be the other diagonal inside of our generic rectangle. So since we already have one of the diagonals filled in, this is a pretty simple question to answer because both diagonals have to multiply to give you the same thing. So I can just take the one that I have filled in already and multiply them together. And if I do that, I get 3x squared times 3, which is 9x squared. Okay. And that actually tells me that I'm going to be putting a 9x squared in the top of my diamond. Now, the other two boxes, this is where the x terms will go. This is the other diagonal, and we put the x terms inside of here, and we know that these two boxes have to add to give us this middle term, okay? Because that's the only piece that's not represented in the box right now. So these two blank ones, this other diagonal, they have to add to give us negative 10x. Okay, and that tells us what we put in the bottom of our diamond. So what I'm looking for is I'm looking for two numbers, right, that multiply to give us 9x squared and add to give us a negative 10x. That's going to tell us how to fill in these two boxes. All right, so two numbers that multiply to 9x squared and add to negative 10x. That is going to be negative 9x and negative 1x. So negative 9 times negative 1 is a positive 9, and negative 9 plus negative 1 is a negative 10. So I'm going to put a negative 9x here and a negative 1x here. And that would successfully fill in my four boxes for the MyOpen Math requirements. Now, to write my equation in factored form, I have to go around the outside here and figure out what my outside dimensions would be. Okay? So if I think about the upper left-hand box, I know I'm going to have a 3x and an x because 3x times x is 3x squared. But I'm going to make sure that I strategically place my 3x on the left and my x up here on the top. So again, the reason I chose those two numbers is because 3x times x is x squared. The reason that I put the 3x over here on the left versus the top is because I have common factors of 3 in this row. Whereas up here, if I look down the column, I do not have a common factor of 3. Okay, so let's keep going. All right, so now we're looking at x times something. There's some number that needs to go here, and when I multiply x by whatever number this is, I'm going to get negative 1x. Well, that has to be a negative 1. X times negative 1 is negative 1x. And then same thing over here, I'm going to take 3x, I'm going to multiply by some number, and I'm going to get negative 9x. Well, that has to be negative 3. 3x times negative 3 is negative 9x. And now when we look at these, right, we can see our factors along the sides. So my factored form looks like this. So I'm going to have 3x minus 1 and x minus 3. There's the factored form of my quadratic, and don't forget that this is all still equal to 0. Now that we're in factored form, solving our equation is very easy. If I use the zero product property, right, if I have two things that multiply to give me a 0, well, one of them has to be a 0. So we can say 3x minus 1 could be the one that's equal to 0, and x minus 3 could also be the one equal to 0. All we have to do is solve these two mini equations, and we find our values of x. All right, so I'm going to add 1 to both sides here. So we get 3x equals 1, and then we divide by 3, and we find that x equals 1/3. Over here, we just add 3 to both sides, and we find that x equals 3. So there's one solution. There is our other solution. All right, so hopefully that helps out with that particular problem. I would practice it a few times, make sure you got it nailed down. If you have any questions, make sure you let me know in the Zoom chat. All right, so different types of equations. We're looking at some exponential equations in this one. So there were some struggles on the quiz with these ones. So I'm going to start off with an easy one, and then we'll get into a more complicated one. All right, so what we're going to do to help us solve this one is we're going to use logarithms to help us out. So I'm going to take the log of both sides here. So I'm going to say the log of 5x, or 5 to the x, equals the log of 9. Okay, so a couple of notes there. You're probably like, what are you doing? Well, what I did was I took both the left and the right-hand side and I put them inside of a logarithm, right? And I do it on both sides because I have to make sure I do the same thing to both sides of an equation. Right? Also notice that there are no bases on these logs, and when we write a log with no base, we get to assume that it has a base 10. All right, now the reason that I did this, the reason I threw it inside of these logarithms the way that I did is because now I can use the power property. Power property tells me that I can take any exponent inside of a log and put it out front of the logarithm. So I can write this as x times the log of 5. And it is still equal to the log of 9. Now to get x by itself, all I have to do is divide by the log of 5. All right, whatever I do on one side, I do on the other. The log of 5 cancels on the left, leaving me with just x, which is what we want when we solve for x, right? And we get the log of 9 over the log of 5. And this is what we would call the exact answer. Okay? In My Open Math, they're also going to want you to find the approximate answer. And this is where we're going to want to grab our calculator. And we're going to type in that expression that we found for the exact answer. So since I used the base 10 log, I can simply use the log button on the front face of the calculator, and I can say the log of 9 divided by the log of 5. And there's our approximate answer, and I'm going to say that is 1.37. So this is my decimal approximation. This is my exact answer. So now let's try that same process, but with a slightly more difficult equation. All right, so notice here that we have an exponential part just like we did over here, but I want to isolate the exponential, right? In other words, I want to isolate this 2 to the x minus 2, which means I want to move this minus 3 to the other side. So I'm going to draw my line just separating the two sides, and then I'm going to add 3 to both sides. That way the 3's cancel. And now I have 2 to the x minus 2 equals 12. Now at this point, I'm going to use my log properties. So I'm going to say the log of 2 to the x minus 2, and I'm going to take the log of 12. So just like I did over here, I just took the log of both sides. Now remember, once we have an exponent inside of the log, I can use the power property to take this exponent and move it out front. Okay, so I can say x minus 2, I'm going to put that in parentheses for right now, times the log of 2. And this is all still equal to the log of 12. And then I start the process of trying to get x by itself. So I notice that we're multiplying by log 2, so I'm going to divide by log 2. I'm going to do that on both sides. So log 2's cancel, and we get x minus 2 equals the log of 12 over the log of 2. You'll notice that I lost the parentheses on the x minus 2 here. I don't need them because I'm not multiplying that expression by anything anymore. All right, so once I move the log over, the parentheses became unnecessary. All right, but now there's only one thing that I need to move to get x by itself, and that is the minus 2, so I'm going to add 2 to both sides. Okay. 2's will cancel. X equals, we've got log of 12 over log 2 plus 2. I just put that plus 2 on the end. And this would be my exact answer. Okay. And then we're going to go to our calculator to get an approximate. So again, I used the base 10 log, so that's real nice. It allows me to use that button on the front of the calculator there. So I'm going to say log 12 divided by log 2. And from there, I can go ahead and hit enter and then just do my plus 2 afterwards, just like that. So I get 5.58. And there we go. So exact answer, approximate answer. All right, let's keep going. All right, so again, the next area that we struggled with was obviously if we struggle with exponential equations, then we're going to struggle with the logarithmic equations as well. So let's go ahead and start solving this one. I'm going to draw my line just separating the two sides. So whenever we have an exponential or a log equation, we want to try and isolate either the exponential part or the log part. So in this case, the log 3 of x, that is our exponential part. I want to get that by itself, which means I need to move this 5. Since this is multiplication, they don't write the multiplication symbol here, but when we have two things right next to each other, we generally assume that it's multiplication. So to move this 5 over, I'm going to divide both sides by 5. Okay, just like that. And then the 5's will cancel, giving me log base 3 of x equals 16 over 5. Now, leave your fraction alone. Do not put this into the calculator and get a decimal. Just leave the decimal alone, because what we're going to do in the next step is we're just going to turn this thing into an exponent using our definition of a logarithm. Okay, so watch what I do here. My base is 3. We're raising 3 to this power, just 16 over 5. So I'm going to go to the exponent. I'm going to put 16 over 5. And then this has to equal x. So at this point, once I have the log isolated, I can use the definition of a log to rewrite it as an exponent. And by doing that, I got x by itself. So this becomes my exact answer. And when you go to put your answer into MyOpenMath, this is what I want to see. I want to see 3 raised to the 16 over 5, no decimals, no nothing like that. All right. Now, once you get this entered in for your exact answer, then you can go to your calculator and get the approximate. Okay, so here's how you do it. I'm going to do 3 raised, and then I'm going to type in 16 divided by 5. So it should look just like this, and when I hit enter, I'll get my decimal approximation. So this should be 33.63. Okay, so exact, approximate. And like I said, the big thing is just don't do anything with this fraction that ends up in the exponent. When you enter that into MyOpenMath, I'm looking for exactly this expression. All right, let's try it again. Slightly more complicated, just one extra moving piece in this equation. So again, my log part is right here, which means I need to move the 2 and I need to move the 8. So I'm going to start with the 8. So that means I'm going to subtract 8 from both sides. That way the 8's cancel. So now I've got 2 times log base 2 of x equals 8, right? Because 16 minus 8 is 8. Now I'm going to move the 2. Since it's multiplying, I'm going to divide by 2. The 2's cancel, and now I get log base 2 of x equals 4. Now the log part is isolated, so I'm going to rewrite this as an exponent using the definition of logs. So my base is 2. It's being raised to the 4th power, so I'm going to say 2 to the 4th equals, well, it's got to equal x. So just by rewriting in that exponential form, we have solved the equation for x. This becomes my exact answer. And then I'm going to go get my approximate answer by typing 2 to the 4th in the calculator. And we get 16. And there we go. All right, guys, that's it for today. Hopefully that review helps you out. If you have any questions, please let me know in the Zoom chat. Have a great day.